Hello, let's talk about vectors a little more. We introduced the one-dimensional vectors. And here we're going to introduce two-dimensional vectors, including vector components, which we use very extensively in solving problems, and also vector addition and multiplications. We use addition extensively. Multiplication will be very useful when we introduce work and the torque, and later in electromagnetics, we use vector multiplications. First, let's review a little bit what vectors really are. Some physics properties, they do not need time, do not need direction, sorry. Some physics properties, they do need direction. So here is collection of different properties. Can you tell which one needs a direction, which one doesn't need? This is how we actually sort it out. On the right, mass, time, volume, color, density, distance, and speed. They do not have directions. Then you might say, like, speed doesn't have direction. No, it doesn't. Speed is the magnitude, or say the quantity number part of how fast anything moves. If we would want to add how fast it moves plus which direction it moves, that is what we use as velocity. So velocity is a speed plus direction. Displacement is distance plus direction. So in displacement, there is more than one piece of information. Not only it tells you the distance, it also tells you which direction. And by the way, displacement, velocity, acceleration, and force, we refer these as one-dimensional along a straight line. When we talk about multidimensionals, then they are along straight lines. Okay, so these are different vectors and scalars. And let's introduce components. Components, each vector is along different directions. And these are some interesting properties where we can really break down the vector into what we call the components. So for example, if a basketball is moving in the air, so it's moving forward, and in the same time, it's going up and down. It's moving along two different dimensions. So we call that two components. At any moment, for example, if a acceleration can be forward, backward, and up and down, so then we can break it down into what we call two components. And this is one of the biggest concepts or biggest ideas in this part of motion and physics. Okay, so let's take a look. For one-dimensional motion, time doesn't have direction. Displacement does have direction because going to the east and going to the west are opposite. Velocity has direction. If you call going to the east positive 5 meters per second, then going to the west will be negative 5 meters per second. Acceleration, if going up means positive, then going down. For example, the Earth gravitational acceleration, usually in the system, we call it negative 9.8 because the direction matters. Okay, so here we focus on introducing two-dimensional vectors and their components. Displacement, if some object is moving along both the x-axis and the y-axis directions, then we call them two different components. So we can use either x and y to describe the two parts of the motion, or we can use a quantity and the direction to describe the motion. Acceleration too, in two dimensions, you use two numbers to represent. Sometimes in this class, we need to add different vectors. For example, forces. Forces are properties that we can actually add up. So if one force is pushing an object this way, another force is also pushing this way, we can add them up. If one force is, in this case, in the horizontal direction, T usually we use as to represent tension. So if the tension is pulling it towards the right, but F usually represent friction. Friction is pulling it back. So when we add these two, sigma means the sum of all the forces along X direction equals to, let me point out here, equals to here, the Tx is positive and minus friction because it's all along the opposite direction. So you see when you add vectors, you really need to know their direction. Along the Y direction, we got the 3 different forces. Later on, we're going to introduce what these forces are so you're going to know them more specifically. Here, we just use this as an example to demonstrate what addition of 2-dimensional vectors are. Along the Y direction in blue color, N represent what we're going to introduce later is called normal force. T is what we use for tension force. Mg means weight. The 3 forces, there are 2 along the upward direction and 1 along the downward direction. You see the coordinate points upward, which means normal force N and tension T along Y direction are both positive because they are along the direction of the coordinate axis. But the weight, mg, is along the opposite side of the coordinate axis, so it's negative. So this is how we add up the components. So first we separate X and Y. We only calculate horizontal in the X direction. We only calculate vertical in the Y axis. And when we multiply vectors, actually we're going to use later. So this is really more of a heads up than having you do all these little calculations. I'll just let you know. There are 2 types of multiplications. We can write 3.5 in 2 ways, right? 3.5 or 3 cross 5. They actually mean the same thing because you get 15 out of both of them. For vectors, the dot multiplication and the cross multiplication mean different things. Vector A dot multiply vector B actually gives us a scalar, which means it gives us a quantity with only magnitude, not direction. So this is called a dot multiplication. We're going to introduce later, for example, to calculate work. We're going to introduce what work is. Work is a force dot multiply displacement. We're going to explain. You multiply these 2 vectors, you get a scalar. Cross multiplication, when we calculate torque, that'll be different. So the force cross multiply a displacement, it gives us a vector. So that's the magnitude here is A times B times the sine theta, and the direction, we're going to use what's called the right-hand rule to decide. So we're going to introduce that again. And this is more like a heads up. So you know we're going to talk about these multiplications. And here we focus on vector components and vector additions.